Hi, in this video I am going to start to explain about the new unit that is going to be magnetism, where we're going to start working with magnets. And today what we are going to do is I am going to explain a little bit of the history of magnet and then the property of the magnet. What you are going to do is, like always, you're going to take notes, and your notebook, then you're going to take a picture and you're going to upload the picture to Google Classroom. Now for today I wrote everything in a document that I'm going to be explaining. Using this document you need to write everything that is in the document in your notebook. Now let's start first with the history. Now magnets, they were discovered over 2000 years ago by the Chinese and the Greeks. Now they don't did it together, but they did it almost at the same time. That's why we're saying that they were discovered by the Chinese and also by the Greeks. Now, but the name magnet, magnetism, was created by the Greek since a rock, or the rock magnetic, was found in the village of Magnesia. Something interesting is this rock that was found in Magnesia. When they found this rock naturally attract and repel different material, but this happened without rubbing or nothing. Was naturally was attracting and repelling different material, and that was something really interesting if we compare with electricity. Okay, now something here is the Chinese and Greeks, they found this magnet like 2000 years ago, but they never used it. They were always thinking that this magnet have some, they were like magic or something like that, but they never used it like for science. It was not in the year 1000 before Christ that the Chinese, European and Persian, they start using magnet for navigations. And this is a really important point in their history, since this magnet helped the Chinese, the European and the Persian to navigate in the water. They use all this magnet to be able to travel a really long distance where before it was almost impossible. We're going to explain a little bit more in the next video about how they use the magnet. But something that I would like to give you is that they realize that if they have a magnet and this magnet is floating on the surface of water, it always point in the same direction. Now they found that the direction was always the north. Now they use this for navigation. Okay, this is really important point that we need to have. Okay, here I have a magnet. Now this magnet, first thing that we need to know is every single magnet always is going to have two sides. Now these sides, or whatever you want to call it, the proper name is going to be poles, and the name of each pole is going to be North Pole and South Pole. Now every single magnet always needs to have the North Pole and the South Pole. That's the first thing that we need to remember. Now let's go for the second part. Now right here I have two magnets. They are exactly the same. Now I want to see what is the interaction in between them. Okay, now first thing, if I have here these two magnets and I have the two different poles, the north and the south, and I move them together, you can see that I have an attraction. Yes, and right here we can see how they stick together. Yeah, we have an attraction force, they want to be together. Now Doesn't matter if I flip the sides. If they are different, north and south, they are going to always attract each other, and we can see right here that we have an attraction force and they want to be what? Together. Okay? Now, let's see what happens if we have the same side. When I have the same side of the same pole, I have here north and north, we can see how they flip to the side, yeah? They don't want to be together. That means we have repulsion. They are moving away from each other. They repel each other, okay? And this happens since they are both exactly the same, north and north. Now, see what happens when I have south and south. When I have south and south, it's exactly the same. They don't want to be together. They are repelling each other. Okay? Now, what is the point right here that you need to understand? First, every single magnet have two sides that the name are pole, that is north and south. Second, the interaction between them is when the poles are different, north and south, we have attraction force, and when they are the same size, same pole, we have repulsion force, since they don't want to be together. Okay. Let's continue with the property of magnet. I explained this in the video, but let's go again. Then here you have all the points. First, magnet have two ends, and these two ends are named poles, and are the north and the south. Now, how you saw in the video, equal poles repel each other, and different poles attract each other. And now, this attraction and repulsion is called a magnetic force. Now, let's here we have table with these examples. When we have north and south, they attract each other. We can see in the vector they want to be together. Now, when we have north and north, they repel each other. They don't want to be together. When we have north and south again, they are different. They want to be together, attraction. And when we have south and south, they repel each other. They don't want to be together. Okay? Also, copy this table in your notebook. That is part of the point that we need to have. Again, working with the property of magnet. See right here, I have here another magnet, but this magnet, I cut this magnet in half. Now, if you see this magnet, when I put it together, it looks exactly like a regular magnet, yeah? Now, see what happened. When I divide this magnet in half, when I put them together, they attract each other. Of course, yeah? We have north right here, we have south on this side. I mean, they're different, they need to attract each other. That's easy. Now, let's see what will happen if I flip one of the sides. Now, this one is north, this one is south, supposed to be exactly the same. If I flip this side and now I try to put them together, I can see that we have what? Repulsion force. They don't want to be together. They're trying to move away from each other. And this is weird because we thought before that this one was north, this one was south. That means something right here is wrong. If they are moving away from each other, that means that these two sides are not different, they are exactly the same. Now, if right here they are attracting each other, they are different. Now, if this right here, when I flip both, we have north right here and south. That means if this side is south and I flip and they don't want to be together, that means that the other corner of the north that was here, now this side is going to be what? South. And this is the key. Every single time that we divide or we cut a magnet, like this one, every single corner is going to have a north and a south. That means right now, this one right here, this side is going to be south, this side is going to be north. And in the other one, we have right now that this side is south, but now this one is going to be north. Now, doesn't matter how many times I cut this magnet, always every single piece is going to have a north and a south. And I can go as small as the atom, and the atom also is going to have a north and a south. Let's continue with the property of a magnet. Now, again, you saw it in the video, but let's go here. When a magnet is cut in half, each piece has a north pole and a south pole. And how I say and how you saw, no matter how many times the magnet is cut, always going to have a north and south. And this behavior is the same up to an atomic level. That means every single piece always going to have a north and south. And we can see here that we have the big magnet with north and south. When we cut it in half, here we have that each part of pieces have north and south. And we can cut it again, and we have north and south, north and south. And we can go again and again and again, and every single piece always is going to have north and south. Now, with this, I will finish the first video. Copy all these points in your notebook, take a picture, and upload the picture. Have a good day.